Before you watch this video, I recommend you to watch the first two videos I made about second order differential equations. First video that I would let you to watch is about second order homogeneous differential equation. Then the next thing is you're going to watch second order non-homogeneous differential equation, introduction in a given constant function. So after you watch these two videos, now you can watch this video. All right? So let's have a continuation about second order non-homogeneous differential equation. So our topic for today is about getting the solution for a given second order non-homogeneous differential equation wherein your function f of x is a polynomial function. Okay? So if you have watched the second video, we learned about getting the solution about a second order non-homogeneous differential equation wherein your function f of x is a constant. Now, what we're going to do now is to learn how to get the solution or at least the general solution for this case. Okay? Now, brief recall once again. This one is the standard form of your second order non-homogeneous differential equation. And of course, your differential equation for this case would be non-homogeneous even only if your function is not equal to 0. All right? Otherwise, it would just be a homogeneous differential equation. Okay? So, your general solution for second order non-homogeneous differential equation is y is equal to u plus v. Okay? Your u and your v are both integral functions. Okay? So, your u is your complementary integral function. You will get your u function by applying what you have learned in getting the general solution of the second order homogeneous differential equation. Or simply stated, what you have learned in getting the general solution of a given second order homogeneous differential equation will be the same method, steps, and techniques on how would you get your u function. Okay? Which is why I recommend you to watch the first video, which is about second order homogeneous differential equation. Then next, you have your v, which is your particular integral function. This function, you're going to substitute something as your v. Okay, you're going to substitute something as your v, but it depends on your function. So if you have watched the second video about getting the solution of a second order non-homogeneous differential equation wherein your given function is a constant, right? You see that you have two conditions, if you recall. And then you have, what do you call this one? You have your V as your K or your KX. Okay? So if you recall on the uh, last recent video, which is about, once again, second order non-homogeneous differential equation, introduction in a given constant function, if your function is a constant function, then you have two conditions. So if your u does not contain a constant term, your v is equal to k. Otherwise, your v would just be kx. Okay? So that would be only applicable for your constant function. But right now, since we are talking about polynomial function, therefore we are going to use your v or your particular integral function as a plus bx plus cx squared. Okay? So once again, your v for this case, if your function is polynomial, this would be v is equal to a plus bx plus cx squared plus yada yada. So how would you use this one? Because this one seems conditional, all right? So for example, let's just say your function f of x is a polynomial. So I have 3x plus 2. So what would be my v? So since I have 3x plus 2, so I will have ax plus b. That's it. Okay, that is my function. Okay, and that would be my v. All right. So do you guys understand what I am doing here? So if not, let me make you another example. So let's just say I have function f of x is equal to 3x squared plus 4x plus 4. So what would be my v here? My v here would be ax squared plus bx plus c. So what did you notice here? Okay. So as you can see, I'm just actually copying the terms, but I interchange the numbers into letters. Just like this one, 3x plus 2. Okay, so from 3x plus 2, it will become ax plus b. That's it. Okay, so once again, I transform 3x plus 2 into ax plus b. So I change 3 into a, and then I copy 2x. Then the constant b will just be, the constant 2 will just become b. All right. So the same thing here as usual, 3x squared plus 4x plus 4. So I copy the same format. I just copied, but different numbers. So from 3 will become a, from 4 to b, and from constant term of 4 will become c. Did you notice? Basically, I copy the format, but I change the what? Numbers into letters. Okay? So one more example. If I have a function of 3x cubed plus x squared plus 2x plus 1, what would be my v? So my v would be ax cubed plus bx squared plus, whoa, whoa, whoa. Wait. Plus cx plus b. See, that's it. The same format, but change the numbers into letters. So that would be like from 3 to A, from 1 to B, from 2 to C, and from 1 to D. All right, that's it. Now let's apply it in this example here. So we have d squared y all over dx squared minus 4dy all over dx plus 3y is equal to 4x plus 1. So as always, your general solution is y is equal to u plus v. Now let's find your u. Okay, wait, they're supposed to be capital letters or in uppercase letters, I mean. So y is equal to u plus v. So let's get your u first. So by getting your u, basically, as I mentioned, is the same way on how would you find the general solution for a second order homogeneous differential equation. So first, you're going to transform this expression into the operator form or the operator expression. So basically, substitute your d all over dx as your d. So we will have d squared y minus 4dy plus 3y is equal to 4x plus 1. Now, what you're going to do is you're going to, what do you call this one? Factor out the y in this expression. So we will have d squared minus 4d plus 3 times y is equal to 4x plus 1. So once again, this is in the operator form. All right? This is in the operator form. Now that you have made it into the operator form, What you're going to do now is to substitute your d as your m and equate this expression into 0. So we will have m squared minus 4m plus 3 is equal to 0. And once again, this is your what? Auxiliary equation. Okay? Now, what we're going to do is to simply get your m values. Okay? So for your m values here, you can either use the methods of factoring or you can just use quadratic formula if you want to take it slowly but surely. Okay? So for me, I can factor this out because the factored form for this quadratic expression is m minus 3 times m minus 1 is equal to 0. Okay, this is the factored form for this expanded quadratic expression. So after you factor this out, let's now find your m values. So we have your m minus 3 is equal to 0, and we have your m minus 1 is equal to 0. So transpose 3, negative 3 to the right, you will have your first m value as your 3, and transpose negative 1 to the right, we will have m is equal to 1. So since you have two m values, and they are both different to each other, but they are real numbers, so meaning your general solution, your u for the general solution would be a times e raised to small ax plus b times e raised to small bx. Okay? So all we need to do is to substitute all you need to do is to substitute small a and your small b as your m values. Meaning, your a could be either of these two values. Okay, you can pick this one as your a and your one as your b or vice versa. So either way, both of them are correct. Okay. So for me, my small a would be 3 and my small b would be 1. Therefore, my u function is a times e raised to 3x plus b times e raised to 1 times x. So in other words, my u function is a times e raised to 3x plus be be raised to x. So that is my u function. Now, we're done here. Let's now proceed in getting your b. I have no space. Don't worry, I can occupy it. Let me just draw a border. Okay, hold on. Let me draw a border here. Let me start from here. Okay. And that's it. So for your v, okay, observe your function f of x. So since your function is equal to 4x, wait. So since your function is 4x plus 1, therefore your v is equal to ax plus b. So what I did here, the same format, okay, but I transformed numbers into letters. So from 4 to a and from 1 to b. Okay? Then after that, you're going to substitute v as your y in the d operator form. So we're going to copy this one. There you go. So as always, copy your v as your y. So we will have quantity d squared minus 4d plus 3 times b is equal to 4x plus 1. Okay. Then, what I call this one, you can simply distribute v to this expression. Okay, so you will have d squared of v. Oh, wait, no, 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 no. It's actually wrong. Wait, wait. Wrong, wrong. I forgot. Since your v is equal to ax plus b, so we will have quantity d squared minus 4d plus 3 times quantity ax plus b. There you go. Okay, that's it. All right. Then after that, what do you call this one? Distribute ax plus b to this expression. So we will have d squared of ax plus b minus 4d of ax plus b plus 3 times quantity ax plus b is equal to 4x plus 1. Okay. So remember that your d is equal to d all over dx. So therefore, this d squared will become um, d squared all over of ax plus b minus times d all over dx of, wait, dx, nope, wait, ax plus b, there you go, then plus 3 times quantity ax plus b, there you go, is equal to 4x plus 1. That's it. And now, as you can see, if you would take a look at the first two terms, right, we have d squared all over dx squared of ax plus b minus 4 times d all over dx of ax plus b, right? That means you're going to get the derivative of these first two terms. Okay? You're going to get the derivative of these first two terms. All right? So here on your first term, right, we have d squared all over dx squared. So meaning you're going to get the second derivative of this term. Okay? So what is the second derivative of ax plus b? So the second derivative of ax plus b is, oh, sorry. The second derivative of ax plus b is 0. Okay? Minus 4 times the derivative of ax plus b is a. All right? Then copy the other terms. So we have 3 times quantity ax plus b is equal to 4x plus 1. Now let's just simplify. So we have negative 4a plus distribute 3 to this expression. We will have 3ax. Oops, hold on. 3ax plus 3b is equal to 4x plus 1. That's it. Now, what we're going to do here, since this is already simplified, we're now going to find your a and your b. So how can we find your a and your b here? So what we're going to do is just basically getting the similar terms on the first side and on the second side. Okay, let me rephrase that. Basically, to find your A and your B, we're just going to use the method about getting similar terms on the left side and the right side of the equation. Okay? First, okay, what is the similar term of your 3ax on the right side? Since we have 3ax on the left side, we also have the similar term of 4x because both of them have x. So we will have 3ax is equal to 4x. Okay. Then another thing, since we have negative 4a, 3b on the left side, we also have 1 on the right side. So why are they both similar? Because negative 4a and 3b are constant terms, okay? Despite that they have letter A and letter B, they are still constants, okay? So therefore, multiplying it with a constant term will give you a constant result still. So therefore, negative 4a and 3b are constant terms, which is similar as 1 as the constant term on the right side. Therefore, we will have negative 4a plus 3b is equal to 1. And now you can now apply methods of system of equations. Okay? So for me, what I'm going to do is substitution. I am going to use substitution method here. So let me start by this equation. 3ax is equal to 4x. Okay. So we have 3ax is equal to 4x. Since both of them have the same x, we can cancel them both, which as a result will have 3a is equal to 4. And now let's divide both sides by 3 to find your a. We will have your a is equal to 4 all over 3. Okay? So since we have a is equal to 4 over 3, we can now further substitute it here. Okay? So we will have negative 4 times your a, 4 all over 3, plus 3b. Wait, plus 3b is equal to 1. So negative 4 times 4 third will give you negative 16 all over 3, plus 3b is equal to 1. Transpose 16 all over 3 to the right side, we will have 3b is equal to 1 plus 16 all over 3. Okay? So this one, we can make this expression into a whole fraction. Okay? So if you're going to use butterfly technique or a technique used in transforming a mixed fraction into a proper or improper fraction, okay, you're going to have 3b is equal to 19 all over 3. Okay? 19 all over 3. Okay? So how did I get 19 wait. How did I get 19 all over 3? So once again, you can use butterfly technique. So right, we have 1 plus 16 all over 3, right? And since we have a whole number of 1, it is a whole number, not a fraction number. So we can have 1 all over 1 plus 16, wait, 16 all over 3. So butterfly technique, multiply 1 and 3. So 1 times 3 will give you 1. The next 1 times 16 will give you plus 16 all over 1 times 3, or multiply both denominators will give you 3. Whoa, hold on. I'm wrong actually. 1 times 3 is 3. Forgive me. Wait, forgive me. 1 times 3 is 3. All right, there you go. So here, 3 plus 16 is 19, then all over 3. So that's how you get it. Okay? So let's go back. Let's get now your b. So by getting your b, let's divide both sides by 3. So we will have b as 19 all over 9. So since we have found your A and your B, we can now further, what do you call this one? What's this? We can now basically further substitute these letters in here. we're going to substitute it here. All right. So since your v is equal to ax plus b, therefore you have v is equal to 4 third x plus your v is 19 all over 9. That's it. That's your v. Or you can factor this out. Okay, you can have your v, wait, you can have your v is equal to 1 third times quantity 4x plus 19 all over 3. That is your v. Okay, so what would be your final answer? Your final answer is y is equal to, wait, y is equal to u plus b. So your u is ax raised to 3x plus b e raised to x. So this would be ax raised to 3x plus be raised to x plus your v, which is 1 third times 1pt 4x plus 19 all over 3. That's it. There you go. So yeah, that is your general solution. So you see, that's basically how you do it. All right. So now let's try our second example. We have 2d squared y all over dx squared plus 5dy all over dx plus 7y is equal to 2x squared plus 11x plus 6. Yeah, as always, your general solution would be u plus v. Okay, so let's start again with your u. Okay, let's start again with your u. So as always, substitute your d all over dx as your capital D. So this would be 2 times d squared y plus 5, wait. There you go. Nope. 5 dy plus 7y is equal to 2x cubed, 2x squared plus 11x plus 6. That's it. Then what we're going to do is to factor out your y in this expression. So we will have quantity 2d squared plus 5d plus 7 times y is equal to 2x squared plus 11x plus 6. That's it. Now, as always, this is your d operator form. Wait, you know what? Let me rewrite it here on the below it, basically. This is your d operator form. Okay? Then what's next? Yeah. We can now further substitute your d as your m and equate this expression to 0. So we will have 2m squared plus 5m plus 7 is equal to 0. So now, let's now find your m values. So you can use quadratic formula or methods of factoring. For me, I'm just gonna factor this out. So if I think that I am wrong, then Well, what can I say? Maybe I'm just gonna use quadratic formula. So I'm going to use slide and divide method if there is a coefficient for your m squared which is not equal to 1. But instead, it's different uh, from 1, basically. So for me, what I'm going to do is I'm going to slide it to 7. So I will have m squared plus 5m plus 7 times 2 is equal to 0. So I will have m squared plus 5m plus 14 is equal to 0. Now, I'm going to think what are the factors of 14, wherein if I'm going to get the product of the two factors, I'm going to get the product of 14, obviously. And if I'm going to add them, the factors I meant, the the sum would be 5m. Basically, I'm going to find two factors that if I'm going to multiply them together, the result is 14. And if I'm going to add them together, the result is 5. So what I can think of is that I'm going to have the factors or the given factors. I think if that's the correct way to say it, that would be 7 times negative 2. But if I'm going to have 7 times negative 2, I'm going to have negative 14, which is that's wrong. If I'm going to have 7 times 2, I will have the product of 14. But if I'm going to add 7 by 2, I will have 9 as a result. So 9 is not equal to 5. So meaning, this is not basically factorable. I'm going to use instead quadratic formula. So let me use quadratic formula. So in here, I will have negative b plus or minus square root of b squared minus 4 times ac all over 2 times a. So your negative b, as always, this is your a, this is your b, this is your c. Your b here is your 5 plus or minus square root of the square of 5 minus 4 times your a, which is your 2, times c, which is your 7. Okay, all over 2 times a, or basically 2 times 2. Now, I have negative 5 plus or minus the square root of 5 squared is 25. Wait, there you go. So, negative 4 times 2 is 8. So, 8 times 7, that would be like 8 times 7. That would be like 56. Wait, let me check if I'm wrong. Yep, I'm correct. It's actually 56. So 4 times 2 is 8, times 7 is 56. There you go. So we're going to, yeah, simplify. 2 times 2 is 4. So if you're going to keep simplifying further, we will have negative 5 plus or minus the square root of um, negative 31. There you go. All over 4. So as you can see, this is obviously an imaginary result. If you would notice, this is already an imaginary result. Okay? So we cannot simplify further since these two terms are not even at least divisible by the factors of 4. So therefore, we can just simply rewrite this as negative plus or negative 5 plus or minus I times square root of 31 all over 4. Okay? And we can divide dot divide. We can decompose them, so we can have negative 5 all over 4 plus or minus imaginary times square root of 31 all over 4. So that is your m value. Okay? That would be your m value. So, since this is your m value, what would be now your u function? Since we have two complex roots, okay, so we will have your u as your a times cosine of small bx plus b times sine of small bx times e raised to small ax. So if you're going to recall again on the first video about second order differential equation, which is second order homogeneous differential equation, this is your, wait, let me, this is your small a and this is your small b. So we're going to have your u as what? Quantity a times cosine of square root of, wait, I think it's better to rewrite it this way. Quantity a times cosine of square root of, wait, x times square root of 31 all over 4 plus b times sine of x times square root of 31 all over 4. There you go. Times e raised to negative 5, 4 times x. That would be your u function. Now, let's get your v. Okay, I don't expect this to be long actually, but yeah. I'm going to use different colors since x is, since your color red is actually, what's that? There's like a term there, it produces too much brightness, you know what I mean? So I'll just use different color. Let's just use color purple or dark purple if that's what you call it. Okay, so let's find your v. So since we have 2x squared, 11x plus 6, so let me rewrite it here. So your function is equal to 2x squared plus 11x plus 6. Therefore, your v would be ax squared plus bx plus c. Now, again, if you have found your v, you're going to substitute it in your d operator form. Okay? So, in this case, wait, I forgot. Let me draw a border. Let me draw a border here. Okay, so, okay. There you go. So now, we're going to substitute your v as your, we're going to substitute your y as your v. So we will have 2 times d squared plus 5d plus 7 times v is equal to 2x squared plus 11x, wait, there you go, plus 11x plus 6. Then after that, since your v is equal to ax cubed plus bx plus c, so we will have quantity 2d squared plus 5d plus 7 times quantity ax squared plus bx plus c is equal to 2x squared plus 11x plus 6. Now, as always, we're going to distribute this one at this expression. So we will have 2d squared of ax squared plus bx plus c plus 5 times d of ax squared plus bx plus c. Then lastly, we have plus 7 times ax squared plus bx plus c is equal to 2x squared plus 11x plus 6. There you go. And remember that your d is equal to d all over dx. So meaning we're going to rewrite it as 2 times d squared all over dx squared of ax squared plus bx plus c plus 5 times d all over dx of ax squared plus bx plus c, then copy the other terms, plus 7 times quantity ax squared plus bx plus c. There you go. And then copy others as well, is equal to 2x squared plus 11x plus 6. So as always, so if you would observe these terms, right, there are in derivative form. So you're going to get the derivative of these two terms. So let's start with the first term. So since this one, your d squared obviously has an exponent of 2, it means it is in second order derivative. So we need to get the second derivative of this term. So by getting the second derivative of this term, I think we will have um, 2a if I'm correct. Wait, let me check. The first derivative for this one, we will have 2ax plus b. So that's your first derivative. And then if you're going to get the second derivative, we're going to get 2a. Okay, I'm correct. So yeah, the second derivative for ax squared plus bx plus c would be 2 times 2a. Okay, 2 times 2a plus the derivative for ax squared plus bx on this term will be 2ax plus b. Then let's copy the rest of the terms. Okay, then on the right side as well, 2x squared plus 11x minus 6. Oh, plus 6. Okay. Now, let's distribute. So 2 times 2a will have 4a plus 10ax plus 5b plus 7a squared plus 7bx plus 7c. Okay, and it is equal to 2x squared plus 11x plus 6. Okay, there we go. Now let's take a look if we can combine similar terms in this side of equation. So it seems like for a 10ax, 5b, 7ax squared, 7bx, 7c. So since all of the terms in this left side of the equation are all unique, so we can now proceed in finding your a, your b, and your c. So what we did in the previous problem is the same way on how we're going to do here. We're going to get the similar terms on the left side and on the right side of the equation. Let's start first with the one that has the highest exponent. So we have 7ax squared. So does this term have similar term on the right side? The answer is yes. We have 2x squared. So we will write 7a x squared is, wait, is equal to 2x squared. That's it. Now next, how about the terms that have x? So we have 10ax and we have 7bx on the left side. Now on the right side, do you think that we have x? The answer is yes. We have 11x. So we're going to write it as 10ax plus 7bx is equal to 11x. There you go. So that's it, right? That's it. So 10ax, 7bx is equal to 11x. Now, lastly, for the constant terms, we have 4a, 5b, and 7c on the left side. Now, how about to the right? On the right side, do you think that we have a constant term? The answer is yes. We have 6 as our constant term. So we will have 4a plus 5b plus 7c is equal to 6. Okay? So that's it. Now let's simplify this to what do you call this one? These two equations. This one, since we have x squared on the left and on the right side, we can cancel them out. So we will have 7a is equal to 2. On this side, we can factor out x on this left side. So we will have x times 10 times a, wait, x times quantity 10 times a plus 7b is equal to 11x. And since we have both x on the right side, we can cancel them out. Okay, so we will have 10a plus 7b is equal to 11. So therefore, this would be your equations. Okay, first we have 7a is equal to 2. And we have your second equation as, hold on, 10a plus 7b is equal to 11. That's it. Okay. Now let's find your a, your b, and your c. So for me, what I'm going to do is to use this equation first. This equation. Your 7a is equal to 2. Okay. Because we can find your a easily. So how to get your a? It's simple. Get your 7a is equal to 2 equation. Divide both sides by 7. Okay. So your a will be now 2 all over 7. That's it. Okay. So you have already found your a, but we need to find your b and your c. Okay. We need to find your b and your c. So let's start first with your b. We can actually find your b if we substitute your a in this second equation. So we will have 10a plus 5b, whoa, no, not 5b, 7b, sorry. 7b equal to 11. So since your a is equal to 2 all over 7, we can have 10 times 1pt 2 all over 7. Then plus 7b is equal to 11. So 10 times 2 all over 7, we will have 20 all over 7 plus 7b all over 11. So to get your b, transpose 20 all over 7 to the right side. So we will have 7b is equal to 11 minus 20 all over 7. Okay. So as always, we're going to make this expression into a whole fraction. Okay, because one of them is a fraction already. So by applying butterfly technique, 11 minus 20 all over 7, and since 11 is a whole term, Therefore, your denominator is 1. So let's start first by multiplying 11 by 7. So 11 times 7, we will have 77. Then next, 1 times 20, we will have negative 20. Okay? All over, multiply the both denominators. 1 times 7, we will have 7. So overall, 77 minus 20 will have 57 all over 7. So that's it. Let me check if I'm correct. Yeah, I'm correct. 57 all over 7. So therefore, we will have 7b is equal to 57 all over 7. So after that, we can now divide both sides by 7 to get your b. So divide 7 both sides. We will have now your b. Whoa, hold on. There you go. We will have now your b is equal to 57 all over 49. So that is the value for your b. Now, seems like we have your a, now we have your b. Let's find now your c value. Let's find now your c. So we have your a and your b. So we can now substitute everything in the third equation, which is your 4a plus b plus 7c is equal to 6. Let me copy that. Okay, so we will have, um, there you go. That's it. I'm gonna write it here so that we can have more space. I'm going to write it here. Okay, that's it. So let's substitute. Since your a is equal to 2 all over 7, so we will have 4 times 2 all over 7 plus 5 times your b, which is 57 all over 49 plus 7c is equal to 6. There you go. So here we will have 8 all over 7 plus, here in your 57, so 5 times 57, we will have 285 all over 49. All right. So let me take a look if there's some changes. Nope, no changes at all. Then plus 7c is equal to 6. Okay. Now what we're going to do is we're going to transpose these terms on the right side. So we will have 7c is equal to 6 minus 8 all over 7 minus 285 all over 49. So what we're going to do here is we're going to make this as a whole fraction. So let's start first with this one since both of them are fractions already. Okay? But first we need to extract or factor out -1 here. Okay, to avoid confusion. So we will have 7c is equal to 6 minus 1pt 8 all over 7 plus 285 all over 49. So in here, we can now use your butterfly technique. So by using butterfly technique, okay, first let's multiply 8 to 49. So 8 times 49, we will have 392. So yeah, 392. Then next, 7 times 285, we will have 1,995. All over, multiplied both denominators, 7 times 49. Wait. There you go. 7 times 49 will give you 343. So combine the values on the numerator, we will have 392. Yeah. We will have 2,387 all over 343. Okay. So in this case, we can simplify this one into 6 minus uh, 341 all over 49. Okay, all over 49. Because both of these values are divisible by 7. So we can simplify this one from 2,387 and 343 to 341 and 49. Okay? So we can now have 6 minus 341 all over 49. It's actually long, it's actually long, right? But that's the only way to get your C value, guys. So once again, let's now proceed. Now that we have already this whole fraction, now we need to make this one into another whole fraction once again. Okay, we need to make this one into a whole fraction. So let's use butterfly technique. 6 minus 341 all over 49. Since your 6 is a whole term, therefore your denominator is 1. So 6 times 49, um, this would be 294. Next, 1 times 341, we will have minus or negative 341 all over, multiply both denominators, 49 times 1, we will have 49. So the value 294 minus 341 all over 49 will give you negative 47 all over 49. Okay? So that is the simplified form of 6 minus 341 all over 49. So we have negative 47 all over 49. So let's find your C. We can now divide both sides by 7. We can now have C is equal to negative 47 all over 343. So that is your C value. And now it seems like we have completed everything. We have your A, we have your B, and we have your C. Now we're going to substitute everything in this V. Okay, we're going to substitute everything in this V. So we will have your V. Wait, let me write it here. Okay, there you go. So we will now have your V as, since your A is equal to 2 all over 7, so we will have 2, wait, 2 all over 7 x squared plus your B, 57 all over 49 times x, and your C would be negative 47 all over 343. Okay, so that is your V function. However, you can still simplify this one. Okay, because these terms are all divisible by 1 all over 7. So therefore, we can have V is equal to 1 all over 7 times 2x squared plus 57 plus 57 all over 7 x minus 47 all over 49. So we can have this as your v function. Therefore, to rewrite everything, your general solution y is equal to u plus v, we will have y is equal to, your u is quantity a times cosine of x times square root of 31 all over, wait, am I right? It's 4. Yeah, all over 4, there you go, plus b times sine of x times square root of, wait, square root of 31 all over 4 times e raised to, what's that again? Negative 5, 4 all over x. Okay, negative 5, 4 all over x. All right, then plus your v, which is 1 all over 7 times, wait, this is not correct. 1 all over 7 times quantity 2x squared plus 57 all over 7x minus 47 all over 49. That is your general solution. See, that's actually very long but challenging enough. Okay, so yeah, that's how you, wait, let me fix the proper spacing. There you go. So yeah, that's basically how you get your general solution. Okay, so I'm glad that we are only finding general solution, but what more if we are going to find a particular solution? All right, so for now we're going to stop right here. Okay, then the next video would be this one, but we're going to find the particular solution. Okay, not only the general solution, but also for particular solution. So we're going to have a practice exercise from second order homogeneous differential equation until second order non-homogeneous differential equation, polynomial function. Okay, so that is all, and I hope you have learned something from me, guys. See you.